go ahead.
Hi everyone. Today we're going to give you a presentation about Wi-Fi in Hong Kong. I'm sure every one of you here should have used Wi-Fi to connect to the internet, no matter on campus, in buses, cabs, or even in coffee shops. So right now, let me give you a brief introduction of the current situation of Wi-Fi in Hong Kong. There are more than 300 government premises in the public area that you can use it freely to connect to the internet. To give you a better understanding of this situation, we have prepared a video.
You can try the other mic. This doesn't sound very good. Maybe try the other mic. Keep going.
It seems like there are some technical problems. We can't play a video, but it doesn't matter. Because we can play it in our computer. Yeah. Okay. The video is actually about that you can use the Wi-Fi in public areas like basketball courts in parks that are operated by the government. And apart from the Wi-Fi provided by the government, there are also a lot of Wi-Fi services provided by companies like PCCW over the territory. So now let me give you a very brief introduction of what Wi-Fi is. Wi-Fi is called wireless fidelity. It makes use of radio waves of about a frequency of about 2.4 gigahertz, and there are actually three commonly used modulation standards, which are IEEE 802.114 G and N. And you can see from the graph that the speed of transmission of the N is the greatest among the three types of commonly used modulation standards. And here we have a table summarizing the three standards. So you can see that all of them are using frequency of 2.4 gigahertz. Yeah. And the speed of transmission is the greatest in N. And this comes to the most interesting part, that is about the modulation standards. Both N and G are using OFDM that our groupmates are going to discuss later. And B is using DSSS, which is not our discussion today. And no matter if it's outdoor or indoor, the coverage of 802.11n is the greatest. And the bandwidth of N is also the greatest. And here the bandwidth is about the width of the band. It's not about the maximum frequency. Yep. So right now, my groupmates are going to give you more details about OFDM.
So what is OFDM? OFDM stands for Orthogonal Frequency Division Multiplexing. So it is a combination of modulation and multiplexing. As we learned in lecture before, modulation means using the baseband signal to change a high frequency radio wave. So why we need to do that? It is because many signals are maybe in the same frequency when they're in the baseband. So we have to modulate it into different high frequencies so that they can be transmitted separately. And also, because some baseband signals frequency, the wavelength may be too big, so we may need a very big antenna. So this is why we have to do modulation of the signals. And next, multiplexing means sharing the bandwidth among independent data channels. It means many signals can be transmitted in the in one carrier, one bandwidth at the same time, and they can be received in the receiving end separately. So maybe we first talk about some issues in modulation. When the signal is modulated, we remember that the signal will be separated slightly. So first, it is necessary for the receiver to receive the whole signal for successful modulation. That means we have to not receive only one of the frequency, but the whole signal. And then the second, it is necessary for different signals to be spaced so that receiver can filter them. So when we modulate it has to be in
No, it doesn't work. The board cannot. No, you cannot do that way. It's broken. It's broken already.
So it has to be separated, separated enough, and then there has to be a gap band between it, so it won't interfere with each other. But this is not the case with OFDM because those signals are transmitted in orthogonal subcarriers. So what is it? It is the carrier will be divided into some subcarrier, and then this subcarrier they are harmonics, meaning that their frequency is integer multiplication of the original frequency, and then they are orthogonal to each other, and those subcarriers will modulate the signals. So Carol will explain further how do they really orthogonal to each other.
Okay, the subcarriers are orthogonal to each other, and it is derived based on our mathematical knowledge. It is chosen that the subcarriers got a frequency of sin nwt times sin nwt, where m and n is the integers. By the trigonometric relationships, this frequency equals to the difference between two cosine waves. So if we take the integrations and subtract them, we can get the area under this curve equals to 0, which means that they are orthogonal to each other in all the integers n and m. And then, yes, and okay, how does subcarriers work? It is shown in the graph. On the left-hand side, there is the incoming signals, and then on the right-hand side, there is some carriers, the subcarrier, and with different selected frequencies. When these two mix together with each other, they will generate different modulated signals, which is shown on the right-hand side graph. These colored waves are the modulated signals. Then they will transmit the data individually. Finally, they will combine to form to restore the original data. The principle is similar to CDMA, but what OFDM does more is that it concerns about the sinusoidal signals. In order to transmit the signals with a lot more advantages. And what are the advantages of OFDM? It has a higher data capacity because more data can be transmitted at the same time with a fixed frequency band, so that it can increase the data capacity as well as the spectral efficiency, because because a lot of data can be transmitted. And then the more important point is that it will not cause any interference because the subcarriers are orthogonal to each other, and this means that even though all the data are transmitted at the same time, they will not the effect of interference will not be significant, as they will cancel out each other due to the orthogonal subcarriers. It is very suitable for today's applications, as every second in Hong Kong there are lots of data to be transmitted by using Wi-Fi.
Recently, they launched a new standard. It is the IEEE 802.11n. So it is the newer standard of Wi-Fi, and you can see the frequency is 2.4 or 2.5 gigahertz. And there is an increased data rate, and it utilizes both OFDM and MIMO. So MIMO is another technology. Usually so far from our research, they can put many receiving thing on the antenna to receive the signal at the same time. And so it is better because it increases the range and throughput of a wireless network. So yeah, this is the end.
Okay, good. from class? Small class? I think it's good. You give a good attempt on explaining OFDM, which we certainly did not cover in the class. So you try to explain it based on what you have learned in CDMA and FDMA. So I think for the final write-up, okay, maybe you can think a little bit more how you can explain OFDM, focus on that a little bit more, and that would be a very nice write-up. Okay, thank you.